Welcome to the shop. I'm continuing in NQALHA Production Run 5 on my new Haas Mini Mill 2 and continuing to explore different ways of improving production and just having more fun with cleverness and fixturing and CAD profiles. And today I'm going to be making some little parts. And little parts are kind of annoying because I need a lot of them. They aren't that big. There's not that much to get done. And on the Tormach, the cycle time was pretty much dominated by tool change. So I'm going to try something I've never tried before, and that is to run 4 little parts at one time on the right and left side of the right vise and the right and left side of the left vise. This is 4 different work offsets that will be managed with the array function in BobCAD. Of course, when I get to the second operation, it means that I have to make 2 new tooling plates, but that shouldn't be much of a problem, and I think everything will go very well. So to start off, and I am starting kind of from scratch here, to start off, I'm going to verify that one function, that a single part is made correctly. I've also made a new set of soft jaws with a smaller ledge. My normal soft jaws have a 300 thousandths ledge, so I can hold a piece of 3/8 or half material and go over the sides a little and not ding up the jaws. For this, I'm using 1/4 inch material, and the cutter will go outside the boundaries of the part, so I don't want to dig big holes in my jaws. So I now have a full set of 4 jaws with 200 thousandths depth ledges, and hopefully everything will work. I'm continuing to get more comfortable and confident using this machine, and I'm making less mistakes, and setup is going faster, and it's all about developing habits, procedures, checklists, and just paying attention. And it's so funny, even while I'm talking about paying attention and trying to pay attention, sometimes I don't pay attention. So it's easier said than done, and the problem comes that, there's different kinds of people. Some people can do very simple tasks over and over and over again and pay attention to each one each time, thousands and thousands in a row. And well, that's not me. I get bored. I start daydreaming. I start thinking about an old hot rod song from the 60s. My little GTO. And then it gets me confused when I should be paying attention to what I'm doing. So I need to just work on that discipline, even if it's boring, even if I've done it 100 times, even if there's almost nothing to think about. Well, almost nothing is not exactly the same as nothing. And failing to pay attention to a simple operation because I've done it 100 times can lead to all sorts of horrible problems on this machine. So everything looks reasonable. This is the little blank, and each NQALHA requires 2 of these, so for a run of 20 I need to make 40, and so that's nowhere near as bad as the drive rollers. Each NQALHA requires 8 drive rollers, so a run of 20 is going to be 160 rollers. Wow, now that's production. So let's see if we can get this pig to oink. Nope, back to the CAD room. And as the number of programs on the screen gets larger and larger, and some of them have similar looking names, there's another place to make a mistake. The getting one with an almost correct name is death on a stick. So I got to be really careful to look over at my setup sheet for the name and number of the part, look at the screen, realize, nope, don't have that one, off to the CAD room. Okay, got my program here, ClampBogie 307, 307, and I have no idea why I started hearing that old Hot Rod song in my head, just for no reason at all. It was a cool song, and nobody cares about cars anymore. Everybody's doing different things. I remember a time when cars and surfing were cool. And of course I never surfed and never had a hot rod, but still. Okay, option stop on, 25% rapid. Change position display to distance to go. Camera error. Well, as I was editing the video, I noticed that some of the GoPro shots taken inside the mini mill were really weird in that they were like sped up, and I eventually figured out what it was, that when I put the GoPro camera into the mini mill, I end up touching the touch screen, and I ended up putting it into time-lapse mode of all things. So I thought somewhat seriously about just tossing the whole mess and saying, well, I'm not gonna post that video. But then I thought, yeah, the part that's boogered really isn't that critical, and it might be worth saving. And I was getting prepared for a big-ass rant about how much I hate GoPro and how stupid the design was, that they have a touch screen on the back where if you're touching the thing while you're mounting it, you can put it in a weird mode. And then I discovered touchscreen lock, so I guess I just wasn't paying attention, which follows the theme of this video. So we now return to our regularly scheduled program. Tool offset 3, which is written on the comment in the G code, and then the next line right below it is the G43H3 that actually executes the tool offset correction. And then over on the active tool panel, it says offset 3, which is like a triple confirmation. So what I'm doing here, I'm doing actually two things. The 1/4-inch material needs to, it's gonna, let me start over again. This is a bogie that holds the bearings for the clamp mechanism that clamps the glass rod or tube in place. The bogie needs to rotate very freely on its axle, and the axle is a 1/4-inch diameter shoulder screw. A shoulder screw is made pretty accurately, and the aluminum extrusion isn't. And so if the extrusion is a 1/2 thou oversize, and sometimes they're 1, 2 oversize, if the extrusion is a bit oversized and you clamp down the shoulder screw, it binds, and that's no good. So I need to reduce the thickness to get proper clearance so that the axle works really smoothly. The other thing is that there's a couple of little ball bearings, little 1/2-inch diameter ball bearings that are screwed onto the bogie, and the face of a typical ball bearing, the inner race and outer race are in the same plane, so if you just screw it to a flat piece of metal, it'll bind too. So I'm reducing the thickness to make clearance for the shoulder screw and cutting a little boss on two sides to provide a little bit of clearance for the ball's bearing. So that's what I'm doing. Let's see if the first part works. It's a somewhat known old program from the Tormach world, slightly modified and updated for the new improved world of the mini mill, but I always treat them as if they're totally new, totally untested, and pay attention, dude. Okay, that was perfect. Okay, tool 31, tool 31, tool 31, 31, 31, quarter-inch drill. Checking my distance to go. All is well. Tool 23, 23, 23, 23, looks correct. Distance to go. And 24, 24, 24, 24, single block. Distance to go looks good. And all is well. Yeah, I'm still wondering about rigid tapping on this machine. So far I haven't had a problem, haven't broken a tap. And on that one, I noticed right before the tapping cycle started, there was a little bit of chip buildup on the tap. And I kind of thought for a moment, do I want to stop it or just see? Because sometimes in the middle of an operation, I'm not looking at the machine and stopping it isn't an option. So I thought, hey, let's just let it go. And sure enough, it cleared itself. Almost. There was a tiny bit of chip buildup, but it was less buildup. So I suspect that these spiral fluted taps that eject the chips up out of the tap, up toward the collet, I suspect that they're designed for unattended long runs on a CNC machine, and I shouldn't be too concerned, but still, I'm just wondering, maybe one of these days, is it going to cause me problems? So that does it for the test. Now, and that's what the little guy looks like. So now, I'm going to deburr. And Gonna try, I've been kind of debating with myself on what the proper procedure for this is. On a previous part, when I was doing the gang operation, I actually put the second part into, let me demonstrate this, put the second part into the vise up against the right vise stop, and then probed this side of the part. And it worked successfully because this dimension was pretty carefully controlled. It actually, the extrusion was going this way and was cut perpendicular, so this dimension was pretty well controlled. On this part, I cut this on the chop saw, and this dimension is not as well controlled at all. So what I think I'm going to do is go into the CAD room and figure out what my distance here is, what my measured distance, actually, let me go back. The measured distance of the vise jaws, and then subtract the nominal size of this part, the size that I was trying to hit, and then set that as the 0 for the next work offset. So I usually cut my parts long, which means the error will be in this direction with a little too much material hanging off, or on this part a little too much hanging off on this side, which is just fine. So by doing it with the nominal dimension, it's logically equivalent to having the stop set on that side. Actually, it's not exactly equivalent, but it's functionally equivalent. So I'm going to go in the CAD room and think about this for a couple of minutes. I think I've got it right. I really don't like typing in lots of numbers by hand. Boy, that's a way to make a lot of mistakes. So I still haven't figured out a plan, a procedure for either automating or, somehow coming up with a, well, like I said, a plan or a procedure to make this less error prone. But I double checked and triple checked just for this run through. I did it by hand. I think it's right. So okay, so, boy, this is going to be exciting. ClampBogie array. Let's see if this is going to work. 25% rapid. Tool offset 3. That's odd. That's very odd. Very, very, very odd. Something is wrong here. And I don't think it's my mistake. Okay, this is just beyond belief. The mysteries continue. I do not know what's going on here. So, I'm going to turn the camera off and try to figure this one out. So it looks like I found a bug in the Haas control. Fortunately, you know, unlike when I bought the Bridgeport as a used machine and the controller was from a long dead company, Haas is still in business. It's a new machine. It's under warranty. I have a service engineer available for consultation. He said, oh yeah, I know that bug. Here, do this. So let's see if he's right. Let's see if, oh, do this fixes the problem. It's probably not as optimized as I'd like it to be, and I'm not sure that I can optimize it. I'm not sure that, oh, there we go. I'm not sure that Bobcat has the ability to optimize it any more than this, but once the rapids are sped up, it should work just fine. Okay, you got the finger on the stop button. Trying hard to pay attention and not think about that hot rod song. Cause I'm the coolest thing around. Little buddy's gonna shut you down. Come on and wind it up, turn it on, blow it out, GTO. And I probably got the words wrong too. So, okay, here we go. Finger on the stop button, paying attention. My little GTO. Stop it. Okay, we got holes. The hole, and nothing but the hole, so help me hole. $832 tap. Power tapping continues to work exceptionally well without any problems whatsoever. Well, after this, after I run this set of parts, I'm going to need to make up a couple of new tooling plates. And there we go. The fix is fixed. The parts are looking good. The additional material is off on this side, which means that I have sufficient clearance for finish on this side, which is what I wanted, because if I would have set that as the reference and then kind of had a little, maybe cut one a little bit shorter, I might risk not having enough on the right side. So all is well. I'm going to turn off the camera, make a new tooling plate, probably make the tooling plate on the Bridgeport. Believe it or not, as wonderful as this machine is, when I'm just making one part, the old Bridgeport is faster. 2-axis CNC is just faster and less error prone than 3-axis because, you know, if the XY goes wrong and I've got my hand on the Z, not going to be any trouble. So I'm going to turn the camera off, make some tooling plates, run the batch, and then come back and hopefully get this pig to oink. The first operation on all of those little parts has been completed successfully, and I made a couple of new tooling plates. These are array style tooling plates, and so they have, each tooling plate has room for 2 parts spaced apart in the appropriate space. And programming the array is actually very easy in BobCAD, but setting the work offsets, wow, there's a lot of potential for error, which of course leads to a rant about G-code and programming CNC machines. As I probably mentioned in previous videos, I've been writing software since 1972, and in the software world we have to manage complexity, lots of complexity, but modern software gives us tools to help us manage this. It gives us things like named variables, named structures with structure elements, templates and macros, and a variety of different compiler tools that help us manage the complexity of a program. And programs can get very complex, and I would argue that managing complexity is the hardest thing that programmers do. And in the world of CNC programming, you get none of this. When you're, I should say, when you're editing G-code by hand. Of course, a CAM system helps manage complexity, but when you're editing G-code by hand, it's all numbers. It's a sea of numbers, and it's like trying to remember this number, that number, this macro variable number. You can't name things, you can't organize things. So I wrote some little quick programs to try to help me manage, to help me probe, say for example, probe work offset 1, and then know that work offset 7 is the array partner of work offset 1, and they always share the same Y and Z work offsets, with only X being different. And then I made a little cheat sheet here to help me organize all of my work offsets, and I try to be consistent where arrays always have matching partners, and when I set one partner of an array, I automatically update the other partner. So I got 4 parts loaded up. I've already run the test once, and yes, everything worked just fine. As I said in previous videos, as I continue using this machine and developing procedures and techniques and checklists and other things that help me, I'm making less and less mistakes, and things are going faster and easier. But boy, there's a lot of complexity to be managed and a lot of room to make mistakes. And like I said before, I gotta pay attention. I gotta, and of course, getting lost in a sea of numbers, sometimes they all start looking the same, and it can sometimes be rather challenging to deal with. And I think I've got it right. I think I've got my procedures under control, and this toolpath has been tested, so I don't think we're going to have any surprises as I show the toolpath. And I've got everything going here. Everything looks like it should be correct. Double check, triple check, check the check. And here we go. Gang, not gang. I use gang for a different, when in my naming to try to keep things under control. When the array is automatically generated by the toolpath program, by BobCAD, I use the term array. And when I generate a multi-part program on my own, I call it a gang. So here we go. Half-inch, 3-flute, Lakeshore carbide, end mill running at 10,000 RPM, 60 inches per minute, doing the entire profile in one depth. This is a 1/4-inch part, so I'm taking a 1/4-inch depth of cut. Probably could go a little faster. I might bump it up, but hey, this is so much faster. When I started making these parts on the Tormach, the tooling plate was a single part tooling plate. I made one part at a time, and doing it in the array of 4 parts has sped the process up so much. It's just amazingly fast. So there we have 4 happy little parts. Process is going good, everything is going nicely. Got my aluminum washers here on the socket screws to keep from dinging up the parts. Parts are looking beautiful. I'm going to be headed to the material supplier later today to pick up some more aluminum so I can start finishing up some of these parts where I didn't quite have enough. So that'll do it for today's video. This is a short one, and thank you for watching. It's been fun.